Welcome to Crosstalk Solutions. My name's Chris, and today we're going to be setting up a secure IoT network for your IoT devices. Now, IoT stands for Internet of Things, and this includes any number of quote-unquote smart devices that require internet or network access. With the growing number of IoT devices hitting the market, they are also increasingly targeted by hackers looking to find ways into your network. So this includes smart plugs, thermostats, televisions, gaming consoles, cameras, refrigerators, the Alexa and Google Home type devices. All of these are examples of devices that should be isolated into their own IoT network so that if they're compromised in any way, they don't have access to your personal computers or network equipment that sits in your quote-unquote main network. Okay, so let's go ahead and take a look at how we're going to set all of this up. So here we have a Visio overview of what I'm going to be setting up today. We have the internet up top. I have an Edge Router 4. That plugs into a Unify switch 24, which then also pushes out to a UAP AC Pro. This is a very simplified version of my network. I actually have a lot more devices in this, but this'll get us where we need to go. And okay, so basically I've got my main LAN over here. This is my secure LAN. VLAN 1, it's where I do all of the management of my network switches and access points. I've got my computers in this network. I've got my phones, like my iPhone, and any tablet devices are in this network. That does not count guests. Okay, so one thing that I'm not showing here is that I do have a completely separate guest network for people that are visiting and they want to, just connect to the internet with their phones. Then I'm going to be creating a second network here. This is going to be my IoT LAN. And I'm making it 192.168.107.0/24, and that's going to be VLAN 107. Now, why VLAN 107? It's an arbitrary number. You can pick whatever you want. For me, though, 107 is IoT in like Leet speak, so it just kind of makes sense, and it's easy to remember that that's where my IoT devices are. And of course, this includes the smart plugs, Rokus, Apple TVs, smart TVs, gaming consoles, thermostats, whatever you have, that everything should go into that network. So now there's two ways to get into this network, wired or wireless. So if we go wired, I have the ability to untag ports, right? So for instance, up in my living room, I have a small 5-port switch. It receives a feed in from my main Unify switch, and it basically gives network access to my PlayStation. There's like an Apple TV up there, a smart TV, and then I think there's a spare port, right? So all of those can be on this IoT network, so I just make an untagged port that feeds that unmanaged switch or that non-VLAN capable switch, and then all of those devices, when you plug them in, are going to be automatically on the 107.0 IoT network. For wireless devices, though, I have my quote-unquote main SSID, I have a guest SSID, and now I have a third SSID, which is what I'm using to ID or identify my IoT devices, so I called it the ID IoT network. Now, that, in my case, is a hidden SSID. If you search on your phone to try to find a network to connect to, you're not going to see that network. I have to manually input that into the devices, and we'll talk about that in just a little bit because it works fine with most devices, but it doesn't work fine with all devices. So we'll talk about how to overcome that challenge a little bit further in the video. None of this means anything without actually putting some firewall rules in place to segregate the IoT network from the secure LAN. So we're going to do a number of firewall rules. The first thing we're doing is we're going to allow established and related traffic coming from any private LAN network to go into the IoT LAN. So I have a ton of networks here, but I always adhere to the sort of standard RFC 1918 private LAN network ranges. And so anything that I've created internally should be able to see the devices in the IoT LAN network, and once a connection is established to those devices, we can maintain that for two-way communication. However, it does not work, it's not a two-way street, it doesn't work the other way around. The IoT LAN does not have access to any other private network other than its own. So then there are a few other considerations that I have here. So I run a Pi-hole for DNS, and so if I wanted a primary and secondary DNS, I'm going to use my Pi-hole as the primary, and I'm going to use the Edge router as the secondary. So the primary is at 192.168.200.10. So I had to open up a port UDP53 over to the Pi hole in the other network. And this is something that you're going to need to do for your own network, not necessarily for Pi hole or for DNS, but for any device where you need to poke a hole through so that your devices can see something in your secure LAN. But it allows you to give very granular control so that you're not just sort of opening the floodgates. You're, surgically saying, look, you, specific network or specific devices in the network, can see this other specific device in my secure network, but only on a particular port, right? So same thing here as in with my Plex, right? So in order to get devices like my smart TVs and the Rokus to be able to see my Plex server, which is in my secure LAN, it probably should be in the IoT network as well, but it is in the secure LAN. We are allowing TCP port 32400 from the IoT LAN over to my secure LAN. Then we're dropping all other traffic, right? So we're basically only allowing those 2 ports through to my main LAN, and then all of the traffic is dropped. However, we are also allowing UDP53 to the edge router. That is for a secondary DNS server, just in case my Pi hole is ever not responding or offline or something like that. Always good to have 2 DNS servers. There is one other rule, and that's to allow for DHCP, or to allow devices to get a DHCP IP address. But we've talked about this enough. Let's go ahead and pop over to the configuration and get this thing set up start to finish. Okay, so here we have the interface of my edge router. This is an edge router 4 running firmware version 1.10.8. I should be very clear though, while I'm running an edge router with a Unify switch and a Unify access point, these same concepts can be applied to any set of equipment that understands VLAN and has a strong firewall. So if you've got a pfSense with Ruckus access points, this should still work. You just have to know the right buttons to press to get the same configuration into those devices. What I'm using, again, is the edge router, and so we're going to take a look at the edge router interface first. Now, I've already created all of this. We can see I have my ID IoT network here. But in order to create a new VLAN, we simply go add interface, add VLAN. In this case, the VLAN ID is 107. The interface is my main interface of ETH1. That's the main interface that hosts my sort of secure LAN. Then for description, we can put whatever we want. I'll put ID IoT. And then for the address, we're going to say 192.168.107.1/24. That's basically giving our network a default gateway address and telling the edge router that this network is a Class C subnet. Okay, so then we can say save, and that is created. Now, of course, I've already created it, so I'm not going to save that. The next thing we need to do is add a DHCP server for this network. So we're going to come over to the Services tab, and we're going to say Add DHCP Server. The DHCP name is going to be whatever you want to call it. I'll call it ID IoT. Subnet 192.168.107.0/24. Now for the range, I'm not going to have any static devices in this network other than the default gateway. So absolutely everything in this network can be DHCP. So the first DHCP address is going to be 192.168.107.2. And the last DHCP address is going to be 192.168.107.254. For the router, that's the default gateway, 192.168.107.1. For DNS1, that is going to be my Pi hole, which exists in my 200.0 network. So we're going to say 192.168.200.10. In an IoT network, it's also a good idea, if you don't have a Pi hole set up, use like some of the public DNS servers that do some level of malware protection. So that would be like 1.1.1.1 or 9.9.9.9. So if you use either of those two in place of what I'm doing here, it should work just fine. So in fact, for mine, I'm just going to do a secondary of 192.168.107.1, which is the default gateway interface. It's the listening interface for DNS on the edge router. But I haven't set that up yet, so let's go ahead and do that next. At this point, I would click Save, and my DHCP server is created. Okay, so to do the DNS portion of this, also in the Services tab, we want to click on DNS, and then from these drop-down boxes, or you can just say Add Listen Interface, drop it down, select the interface that you want DNS to listen to requests on. In my case, it's ETH1.107 or VLAN 107, and then just click Save, and then we're good to go. Finally, this is an optional step, but if you have something like a Google Chromecast, you might want to enable an MDNS repeater. And to do that, we go over to Config Tree, and then you click on Service, followed by MDNS, and then click on Repeater, and you can add a new interface, ETH1.107. That is, again, Ethernet 1 port of the Edge Router 4, VLAN 107, so ETH1.107. And what this does is if, for instance, you had a Chromecast sitting in your IoT network, this allows a device to discover that Chromecast from a different network. Okay, so the MDNS repeater basically just allows that communication to happen. There's a video that we did on how to set this up with a lot more specific MDNS information. I'll put a link to that video up on the screen. Okay, so at this point, we are all done with our setup. Let's go ahead and pop over to Unify. All right, so in Unify, the first thing that we need to do is tell Unify that we have a new VLAN, VLAN 107. So we're going to go down here to Settings, and we're going to click on Networks, and they're going to do Create a New Network. Now, this can be the IoT network. The name can be whatever you want. We're going to say VLAN only, and it's going to be VLAN ID 107, and then click Save. That's all we need to do. We now have that VLAN set up. Now, if you have Unify switches where you're going to be hardwiring devices into the IoT network, you're likely going to want to hardwire those as untagged network ports. So we're going to go over to our switch next. We're going to say Devices. We're going to click on our 24-port switch. We're going to click on Ports, and we're going to look at, for example, port 4. Now, in my case, port 4 is that connection that goes up to my living room, where I've got a TV, a Samsung TV and a PlayStation and an Apple TV all sitting up in the same area. So I've got just a little dumb switch up there. It receives this feed from port 4 and then fans that out to all of those devices. It's not VLAN capable, so I needed to send any traffic going from this switch to that switch as untagged VLAN 107 traffic. So for the switch port profile, I just chose the IoT network as the only network traffic that's going through that connection. Okay, so a little bit of more advanced topic, VLAN tagging and untagging. If you're interested in that kind of stuff, I have a ton of videos on VLANs on the channel. Just search through Crosstalk Solutions channel for VLAN stuff. Okay, now for the wireless side, we can actually add a new SSID. So if I click on Settings and then click on Wireless Networks, we can see that I have this network here that I created. But typically you just want to click Create New Wireless Network. But we're going to edit the one that I already created, and I'll show you all of the settings that you need for this network. Okay, so first and foremost, we're going to enable that wireless network. We want to do a WPA personal as well as a strong security key. Now you're going to be typing this in manually to all of your devices, but just make sure that it's a strong security key so that no one else can get on this network. Now, this next setting, block LAN to WAN multicast and broadcast data. Okay, so this is going to be optional. I have it turned on because I'm not taking broadcast data out of the wireless network onto the wired network. However, there's 1,000 different IoT devices out there, and some of them may require that this be unchecked. Okay, so I have it checked. It might require that it's unchecked. So for instance, if you have a device that relies on broadcast data to be discovered, right, then you might need to uncheck this so that you're not blocking that LAN data. Then down here we have the VLAN that we're going to use. So we want to check that box, and we're going to use VLAN 107. And then down here, here's another setting that is also optional. Prevent this SSID from being broadcast. Now what that does is it hides the SSID so that if other people are at your home or near your home and they're looking for wireless signals on their phone or device, they're not going to see this IoT network show up in the list. It's hidden. Now that means that for the IoT devices that you have, you're going to have to manually enter the IoT network and SSID. Every device that I've added so far does have the capability of doing a manual wireless network for the device to connect to. However, again, there's thousands of devices out there. Some might not have that capability. And another thing you might run into is even if a device does have the ability to manually give it a network to connect to, it still might not work. So case in point, I have a Nintendo Switch. I tried to put the Nintendo Switch on this network. It let me put in the wireless network information, but it would just not connect to that network. So what I did is I came in here, I ticked this box so that it started broadcasting that SSID, and then the switch found it and connected to it no problem, and then I came back in and turned it off again. So just keep in mind that you might have to fiddle with it a little bit to get all of your devices connected. Not every device is going to connect perfectly. Okay, so then there are two more optional settings that you may or may not want to set. You can throttle bandwidth on this network, though I'm not doing it in my case. The reason being is that I've got smart TVs and Apple TVs and Rokus on this thing that are streaming Netflix and YouTube and whatever. I don't want to throttle that traffic. I want that to have full access to my bandwidth, but again, your mileage may vary on that. And then finally, you can potentially enable a WLAN schedule. So for instance, if you only want your IoT devices to be available to connect to this wireless network, or if you only want the wireless network available for your IoT devices to connect to during specific hours of the day, you can also lock that down here with this WLAN schedule. Okay, so once you've got all those settings in there, go ahead and click Save, and your wireless IoT network is now configured and set up properly. What you can do is take your phone or just some device that's easy to connect to a wireless network and then connect that to the IoT wireless network just to make sure that DHCP is working, make sure that you have an internet connection, and all that sort of good stuff. And now let's go ahead and move on to our firewall rules. Okay, so we are back in the Edge Router interface. We're clicking on the Firewall/NAT tab, and we're going to start by creating a firewall group that is going to encompass all of the possible private LAN network spaces. Okay, so basically you would click Add Group here, and then you would come up with this rule. So here we have a Firewall/NAT group, and we call this RFC 1918 ranges. You can just call this local networks or whatever you want to call it. But the networks that we are adding to this group are all of the private network ranges. So that's 192.168.anything. So basically 192.168.0.0/16, which basically the /16 accounts for the last two octets of this subnet range. Then we have 172.16.0.0/12. Again, that is going to cover our 172.16 private address range. And then we have 10.0.0.0/8, which covers our 10.000 class A range. So all of the possible addresses in the 10. Whatever range. So go ahead and save that group. And now we're going to pop over to our firewall policies. We'll see where we're going to use that group in just a second. So for the firewall policies, when you are creating policies, there are three directions or three options for traffic per interface or per VLAN of the edge router. You've got in, out, and local. In and out are a little bit confusing because that is the direction that traffic is flowing in relation to the edge router's interface, right? So for VLAN 107, our example here, the in direction is stuff coming from VLAN 107 into the firewall and heading out to the internet or to other networks or to wherever. The out is stuff that's coming from the firewall into VLAN 107. So out of that port and into that VLAN. I know it's a little bit confusing. Then local is just stuff that's happening on that local network only. Okay, so let's start out with our in rule. That is traffic that is going from VLAN 107 out to either another network or out to the internet. And by default, our default action is going to be accept. So what you would want to do here is add rule set, and then you give it a name description, and then say accept and save it. Let's go ahead and see what that looks like once it's actually created. We can click on configuration. So I called this network ID IoT_in. I gave it that same description. By default, we are accepting all traffic from VLAN 107 into the edge router interface wherever it's going to go, and then we are going to explicitly block that traffic or deny that traffic from hitting our private IP ranges. So basically anything that we just set up in that firewall/NAT group. Okay, so then we are going to accept everything. Let's take a look at the rules that we created for this network. So first and foremost, we are allowing established and related from our LAN networks network group. Let's take a look at that rule. Okay, so this is called allow established related. This is for anything in my private IP ranges, my private LANs, my secure networks that is reaching into the IoT network. We want to establish that connection and allow that connection to remain established. So this rule is enabled. We are going to accept as the action all protocols. And then if we go over here to advanced, we're just going to check the boxes for established and related. And then if we click on destination, our network group is the RFC 1918 ranges. Again, so the group that we created just a few minutes ago. Okay, let's save that rule. Let's move on to the next one. The next rule is allowing our Pi-hole DNS. So if you recall, I have Pi-hole in 192.168.200. It's actually at .10 in that network. And so we want to allow UDP port 53 open through to that Pi-hole so that we can allow DNS requests to happen and utilize that Pi-hole for blocking anything we don't want. So if we go to actions basic on the UDP rule, we can see what this looks like. So we are doing accept. We're doing actually both TCP and UDP just to cover our bases on the DNS requests. And then if we click on the destination tab, our destination is specifically going to only 192.168.200.10 on port 53. So either UDP or TCP port 53. Okay, so we're going to save that rule. And then the next rule is to allow Plex. Now Plex, again, these rules are going to be dependent on whatever services you happen to have running in your own network, but very similar to the Pi-hole DNS rule. Let's take a look at that one. Then we're going to accept only on TCP when the destination is 192.168.200.190 on port 32.400. Again, the best practice is I probably should move my Plex server into the IoT network as well. But since I haven't done that yet, this is how I have it set up now. Okay, so final rule here is to drop the IoT network for any LAN network. So remember, by default, this rule has accept. Okay, so that means that it will take traffic out to the internet, no problem, or out to any other network, no problem. But we want to specifically block our private networks except for the rules that we've already created for Plex and Pi-hole and then the established related, right? So drop IoT to LAN networks. Let's take a look at that rule. By default, we are going to drop as the action all protocols where the destination is that LAN group, right? So basically, these rules are processed in order. So if it hit the UDP 53 for my Pi-hole, it's going to allow that through no problem. But any other port, any other protocol, any other IP address, it is not going to allow that through to those private IP ranges, those reserved private ranges. But then since the default rule is to accept, if we go out to, Google, which is not in those private IP ranges, we are accepting that traffic outbound out to the internet. Okay, so we're going to save that rule. Now let's take a look at our ID IoT local rule. This is for stuff that is happening on the local network itself, so right within VLAN 107. So let's edit that rule set. If we look at configuration, on this rule, by default, we're going to drop all traffic. Okay, so if we've parsed through the rules that we're allowing, then we're going to drop absolutely everything else locally on this network. Drop all traffic. The interface that we're tying this one to is ETH1.107 local. By the way, in the last rule, I think I forgot to mention this part. It's ETH1.107 in for the previous rule, for the in rule. And then this is the local rule, so we're tying it to that interface. And the rules that we have here, just two simple rules. We are allowing DNS to 192.168.107.1 on port 53 for both TCP and UDP. So accept both TCP and UDP, where the destination is 192.168.107.1 on port 53. Okay, save that rule. We are also allowing for DHCP. So this rule says we're accepting UDP where the destination is any IP address on port 67. Okay, so we're basically taking DHCP requests from anywhere within the IoT VLAN. And that's it. Everything else, all other traffic locally on this network is just going to get straight up dropped. Okay, so we are allowing DNS, we're allowing for DHCP, nothing else inside the IoT network itself. Okay, so with those two rules, notice that I enabled logging on both of them. So if we do edit rule set, click on configuration, I've got logging set up on the ID IoT local, and I've got logging set up on the ID IoT in. So how can we actually view those logs and see if our stuff is working properly? Well, to do that, we can bring up SSH, and you're going to want to log into your edge router. Okay, so here I am logged in. And we're just going to say show log tail. And this is going to just do an output of the stuff that is going through this log. The only stuff that I have enabled for logging right now are the two IoT firewall rules. Okay, everything else is turned off. So all of this traffic that you see flowing past the screen here, this is all chatter on that IoT network. Now, let's take a look at some of these and we'll sort of dissect a couple of these log entries so that you guys can sort of just be able to understand what's going on in your IoT network. So let's go ahead and cancel this for a second. And let's just grab one of these at random. So here, let's just take this last one that came through here. Let me move this up. Is that this is a rule that this is some traffic that came through on the ID IoT local interface. So this is basically broadcast traffic in the ID IoT network where the source was 192.168.107.4, and the destination was 255, 255, 255, 255. That is a broadcast, okay? Then we have the protocol was UDP, and it says DPT, it sort of stretches across the line here, but the destination port was 6666. So how do we figure out what this is? So basically some device, whatever device is 192.168.107.4, put out a broadcast on UDP 6666 in that local network. So what is that exactly? Let's take a look here. First thing we can do is go to our services, DHCP, and we can look for our leases. So if we look at the leases for this network, 192.168.107.4 is actually one of my iClever smart plugs. So I've got a few of these on the network. I actually believe it's this one right here. So I've got this one set up, and if I turn it on and off, I will actually see, or I should say if I turn it on and off with the app, I will actually see some traffic on the network that is in the ID IoT in, because it's communicating with the outside world in order to turn the traffic on and off. But this is local traffic. This is broadcast traffic. So let's take a look at it again. First of all, what is UDP port 6666 used for? Let's take a look at that. You can just Google it, UDP port 6666, and it should tell you what it is. In this case, UDP port 6666 is IRC. Okay, so it's basically doing IRC broadcasts every few seconds, probably just as I'm not sure why it would do that as a keep alive, or maybe it's talking to other, similar devices in the same network or something. I really don't know why it does that. But again, this is why, since I don't know why it does that, this is why we want to keep that chatter off of my secure network and onto its own IoT network, right? It makes sense now that we want to separate that traffic. All right, let's take a look at another example. We're going to go back here and let's see if we can find an ID IoT in. So here's one here. ID IoT in. This came from 192.168.107.4. So this is the same device. This is the iClever device reaching out to the internet on TCP port 1883. And you can actually look at the contents of the packet if you want to dig in further, but you would need something like Wireshark to be able to do that. Capture all of the packets from this particular device, and then you could actually look at the contents of this packet to see what it's sending if you really wanted to start digging in deep. But let's just check out what TCP port 1883 is used for. Okay, so TCP port 1883 is the MQ telemetry transport protocol, or MQTT. Now, I'm not sure exactly what that is, but these iClever devices are pretty amazing. They're very, very responsive with the app. I mean, anywhere in the world, you can hit this app and turn these on and off, like this. Watch. On, off, right? So I'm doing that from the app out to the internet and then back, right? And it's very, very responsive when you do that. But let's see where this is actually going. So we can see that it is TCP port 1883, but the destination here is 34.215.132.211. So let's copy that, and let's do an IP address lookup for that IP address. Paste and look it up. And what we can see here is that is sending traffic out to an AWS server, an Amazon server located in Boardman, Oregon. So actually not too far from me. I'm out here on the coast, and then, that is Boardman, Oregon up here. There must be an Amazon data center in that location. So what it seems like to me is that these iClever devices are phoning home, and iClever uses Amazon AWS as their sort of cloud servers. They probably have them all over the world, I imagine. And so when I'm hitting the button here to turn these on and off, it's actually communicating with Amazon AWS, which this device is also communicating with. Okay, let's see if we can look at one more example. And I'm going to turn the logging back on here, and I'm going to put on YouTube on my Roku. Okay, so I actually have a YouTube video playing in the background here, and I turned the volume down, but you can see like how much stuff is flowing past the screen here. It's bringing in just tons and tons and tons of information. Every time I select text and then it disappears, that's a full page of information that's going past the screen here. So let's go ahead and hit Control C, and let's see if we can find some of that YouTube traffic. So the device is 192.168.107.3. Here it is right here. And we can see ID IoT in, that is traffic that's heading out to the internet. From 192.168.107.3, that's the source, and the destination is 173.194.152.10. Let's grab that IP address. And then the protocol is TCP, and the destination port is port 443, or HTTPS, right? So let's go ahead and take a look at that IP address, paste that, look up IP address. Yep, and there we go. So that is traffic that is going out to Google, and it looks like it says Kansas, but I think that's just, it didn't exactly determine where it was. So it's a Google data center somewhere. Okay, so there you go. And really the point of all this is that once you isolate that traffic, it becomes a lot easier to log that traffic. You can also use syslog. I mean, I'm connected directly to the edge router. You could log that traffic to syslog server or something like that instead, which might make it a little bit easier to sift through and read through. But it allows you to sort of take a close look at what these kinds of IoT devices are doing on the network. And then, of course, you can take it a step further and maybe set up alerts or filters or whatever you want, and then start getting really deep into the networking from here if you want. But if you don't want to do that and you don't care, at least you know now that these IoT devices have no access whatsoever to your internal LAN network or your secure and private LAN networks. Not even like a guest wireless network. They cannot get into those networks at all. They can only get out to the internet. Okay, so that's going to do it for this video. What do you guys think? What did I miss? What would you add to this setup? Any additional firewall rules? The only other firewall rule that I should probably add to this, because I know someone will comment on this, is a rule in the IoT in rule set that specifically blocks UDP and TCP port 53 for any other DNS servers, right? So that way, one of these devices can't use its own separate DNS server to get out to the internet. So I will probably add that rule as well, just to block any other DNS servers and only allow the DNS servers that I say are okay. That would be an extra security precaution. But what else is there? So there's a lot to this IoT stuff. I highly recommend segregating your IoT stuff onto its own network. And once you have it set up like this, you now have the ability to start migrating all of your IoT devices into that network. I've migrated about half of mine so far. I have another half that I need to do, and it's just sitting down with the device and, basically reconnecting it to the IoT wireless network. Okay, so that's going to do it. I hope you guys enjoyed this video. If you did enjoy this video, please give me a thumbs up. If you'd like to see more videos like this, please click subscribe. My name's Chris with Crosstalk Solutions, and thank you so much for watching.